physics people, let's do another two-dimensional kinematics problem. This time, a situation where the range equals the maximum height. At what projection angle will the range of a projectile equal its maximum height? Okay, so we essentially need two things. One, we need to know an equation for the range of a projectile, and two, we need an equation for the maximum height of a projectile. And we set those two equations equal to each other. That's how you want to think about this problem. Now, the first part, we already determined the range of a projectile. We derived this in video 40. Okay, so if you want to take a look at how that's derived, if you haven't looked at it yet, I highly recommend you go to video 40 first and then come back to this video. For those of you who have already seen it, let's jump right in. So the range of a projectile is given by x equals v naught squared, the initial speed squared, times sine 2 of the initial angle theta naught over g. Now, for the maximum height, okay, so the maximum height occurs when the vertical speed equals 0. Now, how do I know this? If you were to sketch the motion of the projectile, let's say this is your ground, and your projectile gets launched here at this angle theta naught with this initial speed v naught. It gets launched, it goes up, and then it comes back down. This maximum height, okay, this point up here has Vy equal to 0. We actually did something very similar to this in the previous video, number 43. So if you want, go check that out as well. But that's the idea. At the maximum height, the vertical speed equals 0. So we have to create an expression that allows us to solve for the maximum height. And that's this right here, y max. Assuming that at the bottom here, your bottom y value is 0. Now, with any physics problem, we need to define our positive directions. So I'm going to go ahead and let up and to the right be positive. And because of that, acceleration in the y direction is going to be negative 9.80 meters per second squared. Okay. Now, here's the thing. Notice that in this question, we're not actually given any numbers. So giving a number for acceleration at this point is not going to be the most useful to us. So instead, why don't we just call it negative g, since we've already got a g here. So it's always good to work in terms of letters. So let's just go ahead and do that from the get-go. All right, so we're trying to find an expression for the maximum height when vertical speed is 0. We know acceleration, we know the initial height, we're looking for the max height, we know the final y speed is going to be 0, so why don't we use an expression that involves all of those things? And this is the one. 2ay delta y is equal to vy squared minus v naught y squared. Okay, so now we just expressed that vy is going to be 0 at the top. So you can go ahead and set that equal to 0. And not just that, you see the delta y there? The delta y is actually comprised of two separate parts. So we've got our 2ay y minus y naught is equal to negative v naught y squared. Okay, we just established that our initial y speed, so that should actually be labeled y naught in the diagram. Okay, so y naught is actually 0, so that disappears as well. Another simplification we can do is with respect to the a, we defined a to be minus g. So we'll plug that in. And there's actually one more thing we can do. You see that v naught y? Let's try to get it in terms of variables that appear in this expression, the one for x. Okay, so let's get it in terms of just v naught. And this is how we're going to do it. Your takeoff speed, v naught, is comprised of a horizontal component, vx or v naught x. Remember, v naught x and vx are the same thing because there's no acceleration in the y direction. And you've got v naught y, you've got the projection angle theta naught. So we can actually say that v naught y is equal to, it's opposite this angle, so multiplying the sine of this angle with the hypotenuse, so will give us V naught y. So V naught times sine theta naught. Okay. Now in this expression we have V naught y squared, so it's going to be V naught squared sine squared theta naught. So let's add all of our changes now to this expression. You've got a minus there for the g, so let's put that in front. Minus 2gy is equal to negative. Now it's V naught squared, so it's going to be minus V naught squared sine squared theta naught. Remember, when you square an expression such as sine theta, you put the squared after the sine and before the angle. It's not sine theta with the 2 here, because that implies that the angle itself is getting squared. So just be careful where you put that. Now, before we actually move on, a couple of simplifications. First and foremost, the negatives cancel, so that's convenient. Okay, let's create and reorganize this expression for y. So, moving up here, if you divide both sides by 2g, you get the expression V naught squared sine squared theta naught over 2g. So, because this is the maximum height, I'm just going to go ahead and give it that subscript, since for this problem we know that's the max. So, if we call this equation 2, and our original kinematics equation that we derived for the range in video 40, equation 1, what we need to do at this point is set the two equations equal to each other. And we're going to then figure out what that angle is. So let's set 1 equal to 2. And when we do that, so we're saying that x is equal to y max. So x is V naught squared sine 2 theta naught over g. And we set that equal to V naught squared sine squared theta naught over 2g. All right, let's just start going ahead and making some simplifications, such as a g on both sides in the denominator. Okay, you've got a V naught squared on both sides in the numerator, so those cancel. And you're left with sine 2 theta naught is equal to sine squared theta naught. Now, be especially careful here. Oh, this is actually divided by 2. Be especially careful here not to cancel out the sine 2 theta naught with the sine squared theta naught. Here, the argument of sine is 2 theta naught. Here, the argument of sine is just theta naught. But here, the entire expression is squared. So we cannot actually cancel them out. However, there is something we can do to simplify this, and that is this. Okay, so sine 2 theta naught, there's actually a trig identity here. If we instead rewrite this as 2 sine theta naught cosine theta naught, okay, we now get the expression in terms of just one argument, which is the argument we have on the right. So that's a very convenient next step for us. So let's rewrite it. 2 sine theta naught cosine theta naught is equal to 1/2 sine squared theta naught. I just took the half and brought it to the front there to make it a half. Okay, now sine squared theta naught, another way of writing that, I'm just going to go ahead and do that right now. Another way of writing that is just sine theta naught in brackets squared. Okay, so at this point, I'm going to cancel out one of my sine theta naughts on the right with the sine theta naught on the left. Okay, so let's keep going. Let's get our numbers on one side as well. Let's bring the half over to the left. So that means I have to multiply both sides by 2, making the right side 4 cosine theta naught equals sine theta naught. Let's get all the arguments that have theta naught on the same side. So let's bring this up a bit. So we're going to say 4 is equal to sine theta naught over cosine theta naught. Now, something that you should have learned is that sine x over cos x is equal to tan x. Oh, pardon me. Sine x over cos x is equal to tan x. So sine theta naught over cos theta naught is equal to tan theta naught. So 4 is equal to tan theta naught. Take the inverse tangent of both sides and you're going to get theta is equal to inverse tangent of 4, which is 76 degrees. So there you have it. If you were to launch your projectile at an angle of 76 degrees with respect to the horizontal, then the range and the maximum height will be equivalent. So that's it, guys, for this video. I hope you enjoyed it. Be sure to click that like button if you did enjoy it, and subscribe to Physics in the Flesh so you never miss a video from me. I post every weekday at 12 noon, so be sure to be on my channel at that time to catch my latest video. Thanks, guys, and I hope you enjoy the rest of your day.